Yeah, hey guys, Jet here, back at it with another video. From the previous concepts of the transformer amplifiers, you saw how transformers connected in series work. So this is a series amplifier, this is a single series amplifier, this is parallel, another parallel series connected in with capacitors for safety. This is parallel, this is parallel, and then this is a balancer or a filter. These are transformer, 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 these are transformer. And then we came up with this, keeping the coils outside and keeping the oscillation in the inside. This is keeping the coil in the outside and the oscillations in the inside. No, the coil in the inside and the oscillations in the outside. The coil in the outside and the oscillations in the inside. The coil comes like this, into this transformer, out, 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 into this transformer, then out. Then the coils inside, they are oscillating from this to this transformer, from this to this transformer, from this to that. You get. And then we came up with this, just different connections. These are transformer, this is a transformer, this is a transformer. This is another connection set. This powers this, this powers this, these two power this one powers these two, and then this for two phase or a single phase comes in, comes out. So with the diode it looks like this. So this output, then output, and then this another this is a feedback, using a feedback to improve the amplification. And then we came up with trying to talk analogy of converting mechanical to electrical. So for this system, this is a bigger gear set, this is a small gear set, and then connected to a shaft, connected to a shaft. So when this spins faster. I was trying to balance them, but we saw that it will be having skips. I was trying to, because this is rotating fast and this is rotating slow. I was trying to, initially this was connected, so as this rotates fast, it will force, like a turbo shaft, it will force the initial shaft to speed faster, which increases the speed, which will increase the speed for this, but the skips will be a lot. So this is the same. This is another form of disconnected, connected, positive, negative. So the positive doesn't reach the negative, doesn't connect with the negative, but the connection is through electromagnetic field through the transformer. So the transformer from this side and this side is disconnected. So obviously you pump this side, or depending with your application, you can pump current from the negative back to the positive for more. And then this was like trying to falsify the battery is charging. You need to kudanganya battery. So you have your battery source here. As it comes out, it comes into a transformer through this coil, and then out back through a diode to prevent flow back into this transformer, which will oscillate here. So this side connects with the opposite side through an electromagnetic field in the transformer. So this coil goes like this, so the other coil will go obviously the same and then come out like this. So it can come back in to oscillate and out back into the battery. So obviously when you have like 2 amperes here, you'll have 4 amperes here for number of turns that are half it. So it's like falsifying battery is charging. You have more current on one side than the other. So trying to improve this design here. This can be another form of this can be another form. So this is kudanganya battery with feedback. So from here, this pumps this pumps back this one. This air pumps this and then comes out here more back into the battery. This is another form, now with 4 sets of wires, none of them connected. So this is the voltage in, this will be the voltage out, and then this is now, there is a connection here because this line is going in series, but there is a break here. So this section here is a single wire, this section is a single wire, this section is a single wire. And then there was now a transformer balancer, a 3-phase balancer. So you have 3 lines coming into a transformer, now same number of coils, and then coming out. It should roughly balance it. And then there's a single phase to 3-phase splitter. You have a single input and then 3 wires into the one wire into a coil, and then 3 wires out of the coil. And then this was trying to 3-phase amplification. This line pumps this line, this line pumps this line, and then this line pumps back this line. Trying to improve it, trying to make a 3-phase balancer from a single phase. And then now the other concept that I came up with was this a DC motor made from transformers. So the main concept, it's just a normal brushed motor, but instead of the coils being equally balanced, it's a transformer. One side might have twice the number of coils of the other side. So like for example, this yielded better results. So this section into this transformer is 1, this section out of this transformer is 2, into this transformer is 3, out of this transformer is 4, into this transformer is 5, out of this transformer is 6, into this transformer is 7, out of this transformer is 8. So obviously from the voltage laws and power laws, P, power equals to number of turns times current, and equals to voltage times current. Voltage times current. So from there, power so when you have like a 2 kilowatt power input, so and you have 1,000 turns on this side of the transformer, your current will be 2 amperes and your voltage will be 1,000 volts using these formulas. On this other side, the number of turns is 500, so obviously your current will spike up. You will have 4 amperes on this side, and from the power law, the power between these 2 transformers is the same, so you will have 500 volts 2 kilowatts. And then coming into this transformer, the current is the same on this line, so you have 4 amps into this line, but it's 1,000 turns. So 1,000 turns times 4 amps, you get 4 kilowatts in this transformer. You see the amplification from one transformer to the other transformer. So that's why they are not balanced. You make sure they are unbalanced, so that you get an amplification that ramps up. Eventually it can become a reactor, but because of the connection and the disconnection, it can only spike up into one cycle. So let's complete the cycle. The cycle completes at 8. So 4 amps, 4 amps into this transformer, and and then there's 1,000 tons. So from there and 4 amps you get power of 4 kilowatts. From there 4 amps you get 1,000 volts. So 1,000 volts here. But since these 3 and 4 have the same powers, so power at 4 it will be 4 kilowatts. Number of turns is 500. Obviously you will get 8 amps on this side. 8 amps, 500 volts. So you have 8 amps, 500 volts here. This side and this transformer and this transformer are sharing these sets of wires. So the current is the same. So current into this transformer is 8 amps, but the number of turns is 1,000. So you get a power of 8 kilowatts. Volts will be 1,000. Power between this transformer and in this transformer is the same. So it's 1,000 kilowatts here, but the number of turns are going down, so it's 500. So you get 16 amps on these sets of wires. 16 amps, you get 500 volts here. The same, the current flowing from this transformer into this transformer is the same. So the number of turns is 1,000. 16 amps times 1,000 number of turns, you get 16 kilowatts. 16 kilowatts, you get 1,000 volts. From there, power from this transmission from this in this transformer is the same. So the number of turns on the other side of the transformer is 500. So from there you get 32 amps on this side of the transformer. 32 amps you get. It should ramp up back this one, but since this thing is rotating, you remember these are transformers, so you have transformers as the core, no, as the armature, and then these are magnets. So these magnets are they are fixed. The magnets are fixed. So when they are fixed, the armature is rotating. So to show you how it works, so as the current comes in, you get it comes in through this brush. So this is connected here, comes, rotates into this transformer like this, and then comes out. So this is the north, this is the south, comes out into this wire, rotates like this. So this will be the north, and then comes out, which completes this circuit. So you get, when this is a south, this is a north, this will be a south, this will be a north. So it's going the same. So the wire is coming out from this one here, going like this, completing the north on this side, and then like this, going like this. The north is on the inside, the south is on the outside, and then coming out, completing this set of wire. And then you get for the same for this one and the same for this one. So when you connect your brushes here and here and put diodes here and here, it becomes a brushed motor. But the main concept is the power amplification from one stage of the transformer to the other stage to the other stage. So for one cycle it should have an amplification of roughly 8 times to 10. And this is just for 4 sets of coils. No, not really, there are 4 transformers, so 8 sets of coils, because each wire is having 2 sets of coils. So hope you like it. Please do like, share and subscribe. Thank you.